In this lesson, we move from writing ionic equations to predicting real reactions in aqueous solutions. So, by the end of this video, you will be able to predict whether a reaction occurs, identify precipitation reactions using solubility rules, write net ionic equations for acid-base reactions, recognize gas-forming reactions, and also avoid common exam mistakes. This is one of the most tested topics in chemistry or CHE 110. So, a reaction in aqueous solution occurs only if a driving force exists. Now, what are these driving forces? So, for a reaction in aqueous solution to occur, there should be driving forces, and the first one is the formation of a precipitate. So, whenever there is a reaction in aqueous solution, there should be what? Formation of a precipitate. Also, formation of water, formation of a gas, formation of a weak electrolyte. So, in simple idea, what this just means, it means if everything remains dissolved as ions, then nothing really happens. Nothing really happens. For example, as I said in the previous lesson, that substances are usually dissolved into what ions. For example, potassium chloride, like this, you are going to see that it's going to be something like an ion, potassium plus chloride ions. But again, we notice that insoluble solids are not usually broken down into what? Into ions. So that's where you usually find things like barium sulfate as solid. These, they are not going to be what? They are not going to be broken down into ions. So what they are trying to say now here is, for a reaction in aqueous solution to occur, there should be something like barium sulfate, which has not been dissolved into what? Into ions. So that's where a reaction can occur. Students usually confuse double displacement and precipitation. Now, that comes to our mind is, what is double displacement? What is precipitation? So now, when we are talking about double displacement is just like where it can be two like substances are reacting. Now, when they react, they are going to exchange what? They are going to exchange like the elements. For example, the same example that I gave you. For example, potassium chloride and also maybe sodium nitrate. So now when we are talking about double displacement, this is just whereby this potassium will exchange, it will get nitrate, and sodium will get chloride. So that is double displacement. So they are just two substances reacting, and when they are reacting, they are exchanging the elements, thereby producing what? Products. Now, when we are talking about precipitation, where is precipitation coming from? Now, for precipitation, it's double displacement also, but for precipitation, there should be an insoluble solid formed, and that's where we even say that a reaction in aqueous solution can occur because a precipitate has formed. So that's the difference between double displacement and precipitation. So, for example, we are saying not every double displacement reaction produces a precipitate. So, for example, this one we have sodium nitrate plus potassium chloride. We are going to see this is double displacement, but all products remain soluble, because sodium chloride is going to be formed, which is soluble, and potassium nitrate is going to be formed, which is soluble. Thereby there is no reaction because there is no precipitate. When we are talking about a precipitate, there should be an insoluble solid. And stay tuned, because we are going to talk about how to know if a substance or a compound is soluble or insoluble. Another confusion again is the difference between the reaction between a strong acid and a strong base, with another one which is weak acid and strong base. So these are two reactions. The first one is strong acid plus strong base. The second one is weak acid plus strong base. Now, what you should know is strong plus strong gives complete neutralization. So a strong acid and a strong base, when they react, there is going to be what? Complete neutralization. For example, hydrogen ions plus hydroxide ions, they are going to form what? Water. Weak acids do not fully what? Ionize. So that difference matters in what? In ionic equations. So for this one, weak acid, that is where now we are talking about weak acid plus strong base. But this one that I've given, hydrogen ions plus hydroxide ions is equal to water. This is strong acid plus what? Strong base. And this one, they completely ionize. Now when you are talking about a weak acid plus strong base, this one, they do not fully ionize, they just partially ionize. Yeah. So weak acids do not fully ionize. That difference matters in what? In ionic equations. Now let's talk about precipitation reactions. So just as I said, I defined precipitation earlier. So a precipitation reaction occurs when two aqueous ionic compounds react to form an insoluble solid. So for a precipitation reaction to occur, there should be an insoluble solid what? Formed. So for example, barium sulfate is insoluble, so precipitate what? Forms. So the example is the net ionic equation. Yeah, you may write the first, you may write the balanced equation, what and what, but when you go to the last net ionic equation, you are going to find that barium ions and sulfate ions are going to combine to form what? Barium sulfate, which is an insoluble solid. And this reaction is what? It's a precipitation reaction. Now, having talked of this, now we should explain how to know now if a compound or if a substance is a solid or is insoluble or insoluble. Now this is the most important part that is really usually comes in the exams. So, and it's going to help you, because how do you know that an equation or a reaction occurs, a reaction does not occur? You know this by defining, if by looking at the products, is there an insoluble solid or there is no insoluble solid. And how do we know that? That is where we are going, which is what? Important solubility rules. So these ones, you must memorize them. These one, they are non-negotiable. You must memorize them. So the first one is all nitrates are soluble. All nitrates are soluble, and that's why you might have seen earlier I said potassium nitrate is what? Is soluble. All nitrates are soluble. So whenever you see a nitrate, just know it is soluble. It is not an insoluble solid, but it is soluble. The second one is all alkali metal salts are soluble. For example, potassium, sodium, even barium is an alkali metal, but the only problem why you see barium sulfate is insoluble, it's because of that sulfate, because most sulfates are soluble except barium and lead. So whenever you see barium sulfate, barium nitrate, barium what, it is insoluble. Lead nitrate, lead what? It is what? Insoluble. So all sulfates are soluble except barium and lead. Also, most chlorides are soluble except silver and lead. So whenever you see silver chloride, it's insoluble. Whenever you see lead chloride, it is what? Insoluble. Also, most carbonates are insoluble except alkali metals. So whenever you see a carbonate, just know that it is insoluble except if it is accompanied by what? By a metal. For example, potassium carbonate is soluble, sodium carbonate is what? Is soluble. So this one, try to write them somewhere, because they are very, very, very important, and you should just memorize them. Now someone might ask, you guys are talking about solubility, what soluble, what and what. Now what does this mean? What does solubility mean? So when we are talking about solubility, this is just the measure of how a substance can dissolve in a solvent, like what? Like water. So when we are talking about alkali metal salts are soluble, we mean that they can dissolve in what? In water. So that's just what solubility means. Now let's talk about acid-base reactions. Acid-base reactions. And acid-base reactions, they are called what? Neutralization reactions. So I'm sure you guys, you have started remembering high school now. When you're talking about neutralization reactions, acid-base. Yeah. So when you're talking about a neutralization reaction, this is just a reaction between an acid and a base to form what? Salt and water. So for example, we have a hydrochloric acid, which is an acid. Also we have sodium hydroxide, which is a base. When you combine these two, we are going to see that they are going to form a double displacement, whereby the H, which is hydrogen ion, is going to combine with a hydroxide ion to form water. Then also we are going to have another double displacement, which is going to form sodium chloride, and sodium chloride is an aqueous solution. Water is not an aqueous, but is what? It's a liquid. Again, this leads us back to what I said about the driving forces. I said that for a reaction aqueous solution to occur, there should be formation of a precipitate, formation of water, formation of a gas. As we can see right now, a liquid has been formed, which is what? Which is water. So a reaction aqueous solution as what has occurred. Now the net ionic equation, we have skipped the molecular and the other two steps to writing equations. We have jumped to net ionic equations. I'm sure you guys, you have no problem right now, because hydrogen, sodium and hydroxide ions, or sodium and chloride, they are spectator ions, so that's why they are not in the net ionic equation. So at the end of the day, this is a neutralization reaction, which is an acid-base reaction. This is the most important neutralization equation in chemistry, the formation of what? Of water. Let's go ahead to another reaction, which is gas forming reactions. So we have talked about how water is formed in reactions. We have talked also about how a precipitate is formed in a reaction. Now we are talking about gas forming reaction, how a gas is what is formed. So some reactions produce gases that escape from what? From solutions. So for a acid plus carbonate, what example are we going to give? We are going to give the example of the combination of hydrochloric acid, but I'm going to write the balance equation. So it is hydrochloric acid plus sodium 2CO3, which is hydrochloric acid plus sodium carbonate. This is going to produce, what is it going to produce? This is going to produce, the first one is sodium sodium chloride. This is going to produce sodium chloride, but I'm writing a balanced equation. So sorry guys, it's not that visible because I'm not doing it smartly. So sodium chloride, because sodium and chloride is going to combine there. Then another thing that is we are going to have is water, which is H2O. From water, the last thing that we are going to have is carbon dioxide. So that is where carbon dioxide is produced, and that is where we have said when an acid and a carbonate combine, there is going to be a gas that is going to be produced, and that gas is what? Carbon dioxide. This example, we went direct to the net ionic equation. So we are going to have, whenever, how is a gas formed? So we are going to have for example, two hydrogens, they combine with carbonate ion to produce water and carbon dioxide. So when you're talking about neutralization reaction, there is also the first one we talked of acid plus base. Here we are talking about the acid plus carbonate. The last one is acid plus sulfate. When we are talking about acid plus sulfate, the gas there's going to be a gas that is going to be produced also, which is H2S gas. So let's go ahead and try to do this one. So the first step is always identify ions present. Then exchange ions possible products to form the possible products. Then the third step is check solubility rules that I've said previously. Check if water forms, if a gas forms, then write net ionic equation. So if none apply, then there is what? No reaction. So in neutralization, there is this mathematical expression that I want to give you. So the number of hydrogen ions is equal to the number of hydroxide ions. So keep this formula in mind, where n is the number of moles. So the number of moles, we know from molarity that the number of moles is equal to concentrations times the volume. Yeah. So we know that C is concentration, V is volume. At equivalence point, we have concentration A times VA is equal to concentration B times VB. This is critical in titration problems. Let's go ahead and try to do some examples. So the first example is predict and write net ionic equation. So we have silver nitrate plus potassium chloride. So let's go ahead and try to do this example, guys. So I said the first step is identify ions present. So we have silver ions, nitrate ions, potassium ions, and chloride ions. Then the next thing is exchange. When we exchange, we are going to have silver chloride. The first thing that we are going to have is silver chloride. The second thing is potassium nitrate. So here we go. We are going to have the products is silver chloride and potassium nitrate, and we know that all chlorides are what are soluble except silver and lead. So silver chloride is insoluble. So the net ionic equation is what silver plus chloride ions is equal to silver what chloride. So that's just as easy as that, guys. Let's try to go to do another example, which is an acid-base calculation. So we have 25 milliliter of 0.10 molarity HCl reacts with sodium hydroxide. Find moles of what? Of sodium hydroxide needed. So this is where things try to get intense, but not as they may look. So what are we asked to find? We are asked to find the number of moles of sodium hydroxide needed, and we know that the number of moles is equal to concentration times what? Times volume. So if we can find what is the concentration of sodium hydroxide? So the values that we have been given is for hydrochloric acid. So here is how we do it. The first one is convert volume to liters. Here we go. We are going to have that is of hydrochloric acid because that's what we have been given. So then we are going to find that the number of moles of hydrochloric acid when we multiply concentration times volume. This is for hydrochloric acid, by the way. We are going to find 0.00250 moles. Then we know the ratio is 1 to 1 because the number of moles of hydrogen ions should be equal to the number of moles of what? Hydroxide ions. So at the end of the day, the number of moles of sodium hydroxide is just going to be equal also to be 0.0250 moles. So what have we done, guys? What we see is hydrochloric acid is an acid, sodium hydroxide is a base. So what we are just trying to say here is we are just proving this formula we gave earlier, which is number of moles of hydrogen ions is equal to number of moles of hydroxide ions, because number of moles of hydrogen ions is acid, number of moles of hydroxide ions is a base. So this is just similar to what we were asked here, what we are asked in this example, because in this example hydrochloric acid is an acid, which we are going to say it's hydrogen ion, then sodium hydroxide is the base, which we are going to treat as hydroxide. So at the end of the day, the answer we find for hydrochloric acid is the answer that we are going to use for sodium hydroxide, which is the base of the what? Reaction. Example 3, we have hydrochloric acid plus sodium hydrogen carbonate reacting. What are we going to have? The net ionic, this is just like an example here. What are we going to have? We are going to have water and carbon dioxide. Always know that whenever an acid is reacting with a carbonate, we are going to have water and what? And the carbon dioxide in the net ionic equation. Now the question that we should ask ourselves is, why do these reactions proceed? These reactions are proceeding because a solid is being formed, a gas is being formed, or water is being formed. And this removes species from what? From solution. And this shift the equilibrium and drive the reaction forward. Let's go ahead and give you the student like the practice problem that you should write in your books, for future use. So predict reaction and write net ionic equation. So we have calcium chloride and sodium carbonate. So the answer is there. So go ahead and try to solve them and see if you can also have the same answers. So predict reaction and write net ionic equation. The second one is, does reaction occur? So there is going to be no reaction. So go ahead and find why there is going to be no reaction. The third one is write net ionic equation. We have sulfuric acid and potassium hydroxide. So that's the net ionic equation. Go ahead and try to do that to see if you are going to have the same answer. So that's the end of this video, guys. Here are just exam tips that are going to help you. The first one is always check solubility before concluding a reaction. Do not assume double displacement means reaction. Always include correct physical states. What do you mean physical states? Is it a solid, is it a liquid, or aqueous? Cancel spectator ions carefully. In titrations, convert milliliter to what? To liters. So what's our conclusion? In this lesson, we covered precipitation reaction, acid-base neutralization, gas forming reaction, reaction prediction, titration relationships. the next video we are going to move to oxidation reactions, assigning oxidation numbers, balancing redox reaction in acid and basic solution. Don't miss the next video, and also don't forget to like and subscribe for